Hi, my name is Hans de Sterk, and I will give you a little bit of an overview of the course CS770 Numerical Analysis. So this is my email address. I'm a professor in applied mathematics, also the director of Waterloo's Computational Mathematics Center. The lectures for this course will be Tuesdays and Thursdays in MC 4040 from 2:30 till 3:50. And the lecture materials that you will be provided with is PDF course notes fully typed via the course website, and also the set of board notes, like handwritten board notes that I use will be provided in PDF as well. So what is numerical analysis? So numerical analysis is the area of mathematics and computer science that focuses on inventing and analyzing algorithms for numerical computing, so computing with floating point numbers. And there are many applications in computational science and data science, so science, engineering, big data, machine learning, finance, and so on. And the focus of numerical analysis is to invent and analyze methods that are accurate, efficient, and scalable, so that you can apply to large amounts of data. And numerical analysis is different from algorithms for discrete mathematics, algorithms that work with integers. For example, graph algorithms, combinatorial optimization, sorting, and so on. And you have other courses for that, but really in numerical analysis, we really focus on numerical computing with algorithms with floating point numbers. Okay, so in the past decade, mathematics-based large-scale computing has indeed become a prevalent means of discovery and of getting things done in almost all areas now of research and technology. So originally, numerical analysis was focusing on problems from science or physics and engineering, but more recently, there are many more applications. For example, machine learning and data science. There's a lot of numerical computing going on there to train your neural networks and evaluate them. Web search, social network analysis, computer graphics is a big area as well, computational finance, biomedical computing, data mining, business analytics, cybersecurity, big data analytics, and so on. And so numerical analysis, sometimes also called scientific computing, is the field of study that invents and analyzes numerical algorithms for solving real-world problems on computers. Okay. And so what we focus on this course is we start with some motivating applications from computational science and data science, like some problems related to science and engineering, and also like a recommendation problem, for example, from computer science. Then we spend quite a bit of time on the numerical linear algebra to deal with problems in numerical analysis. So different ways of solving linear systems and least squares problems. That's about half of the course. So we spend quite a bit of time on that. We also spend some time on numerical methods for deep neural networks, and also for ordinary differential equations and for nonlinear equations. Prerequisites: it's useful if you have a basic undergraduate course on numerical methods, or at least on like computational algorithms. But it's also not recommended to take this particular course if you've done a lot of numerical linear algebra in previous courses. For example, if you've taken this course, there would be quite a bit of overlap, right? So there is a substantial introduction to numerical linear algebra. So the way how the course will run is that we will have the lectures, then we will have 6 assignments on these various topics, including the recommendation and the machine learning, and then also a bunch of other problems. And the assignments will have partially theoretical problems and partially numerical implementation problems, where you can use MATLAB or Python or other languages that you like to use, like C++. But most people use MATLAB, I think, or Python to do the computational parts of the assignments. The assignments count for 50% of the grade, and then the other 50% is a final exam towards the beginning of the exam period. It's a closed book exam, but you can bring a sheet of paper on which you can write formulas, so you don't have to memorize things at the level of formulas, but it is a closed book exam that will be held during the final exam period. This course is a good preparation for other computational or numerical grad courses at Waterloo. We have a numerical PDs course in the winter semester. There's also this new course on advanced numerical methods for computational and data sciences that's also taught in winter. We have continuous optimization, for example, computational linear algebra, numeric computation for financial modeling, fundamentals of optimization, optimization for data science, neural networks, deep learning. They all use a lot of numerical methods, numerical computing. Okay, and then of course, what is different is, like I said, the discrete mathematics, design and analysis of algorithms, that focuses on different types of computational algorithms, not on numerical computing. Okay, so then just to finish, properties of a good numerical algorithm: has to be accurate, so good approximate solutions, it has to be fast and scalable, and that's what we will focus on. We will have in mind the things that, like the fact that computers become more and more powerful, like there is this Moore's law. So if you have in time, the computers have become more and more powerful in terms of floating points operations per second they can achieve in an exponential way. But then what is really important if you want to use that power of computers is to also use good algorithms. For example, if you solve a linear system, if you do the standard way, it scales order n to the power 3, where n is the number of unknowns in your linear system. And if you want to solve large systems, then it would take a lot of time, even on very fast computers, to solve these problems. But then we will learn about much better algorithms that scale much better, and they will really give you much faster answers for really large problems. And that's the kind of thing in this course that we are interested in. So if you have any further questions, feel free to email me, and I hope to see some of you in the course starting next week. Okay, thanks a lot.